Hi, today we'll be solving this question maximum equal frequency. So this question is basically a problem in which we are given with a array nums and we need to figure out the length of the longest possible prefix such that if you remove exactly one element from the prefix, we will be getting a resultant array that has elements having equal frequency. Like in this example, if you look at this nums array and we consider this prefix array till right here, which is of length 7, that is this one. If we remove the number 5 or the element 5 from this, we will be getting this resultant array. Now in this array, we can clearly see that every element that appears has equal frequency, like 2 appears 2 times, 1 appear 2 times, 3 appear 2 times. Hence, the answer is 7. That is the length of the longest prefix array. That satisfies the condition. So in this question, first of all, let's see what a prefix array means. So a prefix array is an array which starts from the very leftmost end of the whole array, and we can include elements one by one till the rightmost end. So the only condition is to fix the leftmost end and the right end can be varying. So for this question, what we'll do is we'll iterate from the very the smallest prefix array and gradually increasing the size of our prefix array and figuring out whether the each prefix array satisfies the condition or not, and thereafter updating a result. Let's say we have this string AA, BB, CC, and D. Now, for the sake of explanation, I've just changed the numbers into letters for easier understanding. Now, let's say we are given with this string and we want to do the same operation. Not a string, but it's an array of elements. So, um, so imagine this being a prefix array, one of the prefix array which we are observing. So we can clearly see that if we remove D, we are left out with elements having equal frequency. That is A appearing 2 times, B appearing 2 times, and C appearing 2 times. But how do we do that? So an ideal, uh, the first thinking, the first thought which comes to our mind is that to make a hash map of the frequency of different elements. And why is it so? Is because since we are dealing with the frequencies and we are eliminating numbers or the elements based on the frequency, hence it's very obvious to make a frequency hash map. So I'll name that freak, and here's the mapping. Now we can see clearly that A is the element and the corresponding value is the frequency of that element. So in a similar fashion, the rest of the remaining elements are filled in the hash map. Now with this hash map, it will be easier for us to determine which element we need to remove. But there's a problem. For this question, since we need to figure out element that after removing, the resultant array will have equal frequency. So we have to make sure that the rest of the frequencies are equal and we have a separate individual frequency um, element which we can actually rule like over here. So the problem over here is we have to iterate through the entire hash map and we have to make sure we need to observe and we need to make sure how many different um, different types of frequencies are present. Okay, had had this b been 3 times, so it would fall into a different category. So we need to take care of that. That's why we need to iterate through the entire hash map. A clever way or interesting way to solve this problem is basically group on the basis of the frequencies. And why is it so? It's because since we are caring about the the different, you know, categories, and we are classifying different elements based on the frequencies. So why not group them and store that information in some sort of a data structure? And hash map is an ideal data structure for that, because that will help us to look up in a very less amount of time. So as per the idea, we will be grouping elements or the frequencies and as per the counts. So I'll name that hash map as count freq. That is short form of count frequency, and it will look like this. So basically, what I did over here is this element. Okay, so this entire key value pair is one element, not just the key, not just the value. The key value pair is one element of the hash map. So what does this element corresponds to? So this element says we have three groups having two frequency. Okay, and what are those? Right here. And specifically talking about that, we have AA as one group, BB as one group, CC as another last group. So we have three groups in total having two frequency. Similarly, the second element in the hash map, what it says we have only one group having one frequency, which is right over here. And that is D is the group having one frequency. Now, now before moving on, let's just see how will we handle the how will we actually, access the key and the value inside the count frequency hash map. So for that, what we'll do, we'll actually introduce a key and value picker, that is basically a pointer, and I'll equate it to count frequency dot begin. So what it will do is basically create a pointer that is pointing to the very first element of the hash map. Now at this point of time, in this example, what we have is only one element, so it will just point to the first element. In fact, irrespective of how many elements are present, the this dot begin, what it does is it points to the first element of the hash map. So I'm using a C++ implementation. Now, to access the key and value pairs, we have to use the property of pointers. So to do that, what we'll do for key, we'll use a arrow sign and then FIRST keyword first. So with that, we can actually access the key, that is 2. All right. And for the value, we'll use arrow SECOND, that is second. So this is the way we can actually access the key and value individually. But what if the hash map has two elements? So things won't be much different. Over here also, we'll initialize a pointer that will point to the first element of the hash map. Then the key 1, that is the key of the first element, will be can be accessed by this command, and the value of the first value 1, that is the value of the first element, can be accessed by this command. But what 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 if we need to access the key and value of the second element? So to do that, we'll just increment a pointer, which will make the pointer point to the second element. And using the same formula or syntax, we can access the key 2, that is the key of the second element, and value 2, that is the value of the second element. Now coming back to this diagram, over here we can actually see that if we remove D, we can get the desired output, right? So removing D is giving me a solution. So, and how can we do that is by looking at this count frequency hash map. So Virtually, this count frequency hash map is a summarized view of the whole string or the whole array or the frequency hash map, right? And it is because we categorized or we grouped the uh, elements based on the frequencies, okay? And and since and the and I mean that the different frequencies will be categorized into different um, as a different elements in the second hash map. That that's why the size of the hash map will vary according to the different number of different frequencies. So that's why the size of this hash map is important as well as the values present inside this hash map. So my point is we don't need to, look up to this again and again. We just can look up to the second hash map to um, to look for an answer. Hence, let's divide the whole question into few cases. So the very first case is when we have the size of the hash map equals to 1. That means we only have the very first element. I mean, the there's only one element present in the hash map, that is in the count frequency hash map. So the first subcase which arrives is this one where every element in the array is different, or you can say unique. So if we remove any one of the elements, let's say D over here, we can actually achieve the remaining elements having equal frequency. Okay, so what we're doing here is, since every element is unique, hence every element forms a group, a different group. So that's why we have the total number of groups that we have right here is equal to the length of the array, that is 6. So if we remove any one element, that means we are removing the entire group or the entire element, and we are left out with the one less group. So that this means that this particular prefix array, what we have, is the answer. And in the count frequency hash map, since the number of groups is equal to the length, that's why we will have the value of the count frequency is equals to the length, that is 6, right, in this example. So the condition for to check this subcase is value is equal to length, that is value is equal to prefix end plus 1. That means prefix end, let's say it's a pointer pointing to the end position of the prefix array. The second subcase, however, is the opposite of this case. Is in this case we have every element equal. So this actually forms one single group. So removing any one of the element will actually result in a group having frequency one less than the previous, right? So it won't change and the answer would be acceptable. So this case is actually acceptable. So since the group is one in the count frequency hash map, the value would be equal to 1. So to detect this case, we'll be just checking if the value is equal to 1 or not. And the last case which comes over here is the subcase 3. Over here, this has basically groups that is less than length and greater than 1. What I mean by this is that the first case is the extreme case where there are maximum number of groups possible, that is the length equal to the length of the array, right? Because every element is forming a different group. But subcase 2 is the minimum, the uh, lower extreme of the case possible, where all the elements form one single group. Okay, So subcase 1 has maximum number of group, subcase 2 has minimum number of group, and subcase 3 is basically in middle of these two conditions. So it will have either three groups, I mean groups having three frequencies, groups having four frequencies, but the number of groups will be lying in between these two subcases. So let's say for example I have considered this um, mm, prefix array. Hence over here, if all the groups have equal frequencies, already have equal frequencies, and if I try to remove any one element from the group, it will uh, it will destroy the balance of the frequencies, and the group, like let's say if I suppose remove H, so this group won't be no longer be of two frequency, it will become one, and hence this won't give us the solution. So there's no way of removing one element and also getting elements having equal frequencies, right? So this case is not the desired case, hence we have to look for the subcase 1 and subcase 2. Now what if the size of the count frequency hash map is 2? That means there are two elements in this hash map. So there are mainly two cases, but we need to handle few conditions to make it easier to code, and the code becomes much cleaner and less error prone. So let's look at the very first example. The first example is when we have different groups having equal frequency except one group having one frequency. So in that case, we can simply remove that alone element such that the remaining group will be then have same frequencies. So this will be the answer, right? So the corresponding hash map would be having one and one key and one value, right? One key value pair. So what this means is we have one group having one frequency. That is right here, F. So what this condition is that whatever value, either the first value or the second value, that is value 1 or value 2, whatever the value is, like in this case, the value 1 is equal to 1, then if the corresponding key is also 1, then that means that indicates that it's some sort of this string, and we can actually remove it. So we don't need to add anything or subtract literally in the array or remove any element in the array. We just need to consider the length of the existing array and store it in the answer. So whenever we come across this kind of situation where we have one as key and the corresponding value is also one, then we know that the string or the prefix array which we are looking at is the desired answer, and we need to update our result accordingly. So this case is basically when value 1 is equal to 1 and key 1 is equal to 1, then that's a possible scenario. So the next case is when we have a group which is have a higher frequency, a single group having higher frequency, and the remaining groups having lower frequencies. So a single group that is right here, that is when the value value 1 is 1 and the corresponding frequency is a higher frequency, then we can actually what we do, we can actually cancel out the F from the higher frequency or the one of the elements in the higher frequency group so that it gets converted to the lower frequency group. So to do this, what we need to do, what we need to check is basically one thing. We have the value is equal to 1, that is value 1 is equal to, if value 1 is equal to 1 and the corresponding key, that is key 1, is greater than key 2, and specifically by 1. Why? We'll look into that later on. Okay, now now I assume that the value 1 is equal to 1. Okay, that's the case. But what if the value 2 becomes equal to 1? So just a swap. It's the same thing what we're doing. Okay, so same thing, just the value 2 is equal to 1, so the conditions will uh, change a little bit, but the concept is same. Okay, so if the value 2 is equal to 1, then key 2 must be checked. Okay, so key key and value pair, the corresponding key and value pair must be equal to 1, and that time at that point of time we can actually say that this string matches our criteria, where we can cancel out the alone group. Similarly, talking about this case over here, we'll have value 2 equal to 1 and the corresponding uh, frequency is higher, right? Where we can cancel out one element from the higher frequency group. But let's come back to this question. Why is this 1? Okay. Why not 2? Why not 3? Or, this one is basically corresponding to this condition 1. So let's look at example where we have for F having 4 frequency, H having 2 frequency, K having 2 frequency. So right here, instead of 1, it is basically 2, right? So why is it? Okay, so the frequency of this is 4. Okay, and we are only allowed to cancel out one element. So even if we manage to cancel out one F, we are still remain we are still having 3F and 2H and 2K. So that still isn't the desired condition. So we have to remove another F, which is not allowed in our question. So this is the case which why it fails, and we need to specifically have y plus 1. Another question which comes in mind is, what if uh, this frequency and this frequency is swapped? Or in other words, why the corresponding frequency to corresponding key to the one frequency needs to be larger? Why not, you know, the difference must be 1? Why it needs to be specifically in this order? Let's look at an example. Over here, we have three frequency groups. So, I mean, two groups having three frequency. So F is occurring 3 times, H is occurring 3 times, and K is occurring 2 times. So right here, it feels like we can add an extra K to it, so that will make the whole prefix array having equal frequency, but we cannot do that. We are not allowed to add. We are actually allowed to cancel one element. So, so if even if we manage to cancel out one element of the group, we will make edge occur 2 times, K occur 2 times, but still we will remain with F three times. So that doesn't solve our problem. Hence, this is also a case which doesn't satisfy our condition. So it's very vital to have the higher frequency corresponding higher key, frequency corresponding to the 1. Okay, so this key, that is the higher y plus 1, must be corresponding to 1. So that's why we have a condition of the whatever value is 1, that key must be greater, right? So over here we have value 2 as 1, so key 2 must be greater. And by what? By 1 value. Now last, it's a special case where we have both value 1 and value 2 equal to 1. So there's nothing different. There's nothing different. We have both the values equal to 1, and just like in the top cases where we actually exclude the single element, over here also we have a key value pair, okay, that both have 1 1, So that way we can actually cancel both of them, this alone group. Okay, so if the if if key one is equal to one, then this satisfies. If key two is equal to one, then this satisfies. Okay, if key one is equal to one, then it's similar to this condition. If key two is equal to one, it's similar to this condition. So that's what goes on. And again, similar to the bottom conditions, we have a we have a frequency group which is higher than the rest of the groups. Okay, so right here we have, and that too by one. So right here what we have is we have a one group having higher frequency than the remaining groups. So we can actually cancel one element from that. So we just check if we have a value is equal to one and the corresponding key is greater than the other key. So it doesn't matter which key key is greater than one because both of the values are equal to one. So it's sort of like a bonus case. But it might look like a huge task, but it's not. You can see that the above case, the top case, is just canceling out the alone elements, right? And the bottom case is just canceling out one element from the higher frequency group. That's it. So these are the two cases which we need to consider. Although and why I'm distributing it is because first of all, I'm doing these two cases because I'm using an unordered map, which increase the time, makes it faster. That way, it's basically less error prone, right? Okay, so let's look at the case three, that is the frequency size having 3, 4, 5, or 2n, anything greater than 2. So the first example which we can look over here is having frequency 3. That means we have 3 elements in the hash map. Let's say this is a string where we have k occurring 4 times, d occurring 2 times, d occurring 4 times, a, b, c all occurring 1 time, and a, b, c occurring, oh, I'm having frequency 1, and f occurring 2 times. So 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 if we try to make every group in a same frequency, okay, so what we do is basically by removing any one element of any group, what we are trying to do is we are trying to convert that group into the desired other rest of the groups. Okay, so if you remove this k, right, let's suppose one of the k's, so it will be converted to 3 k's, right? And that's a different category having 3 frequency. But that won't solve our problem because we are still remaining with other groups, so which are unequal, other different groups. So this case is not our ideal case. And you can imagine when we increase the size of the count frequency, let's say 4, right here also we have a similar thing where even if we try to remove from the any one group, we cannot obtain a desired uh, solution. So this prefix array is actually not the desired condition. So no matter how much elements you grow, or you make the increase the number of elements in the hash map, that that substring won't be actually considered as a solution. Another obvious way to look at this condition is if we have different groups, and the only way to convert all the groups into same frequencies is basically removing elements from the higher groups. Okay, so if we have a higher group that is over like here, if we remove D, we'll actually convert this D. Initially it was 4, but after removing 1D, it will become 3D. That will fall into the G category, right? But that won't solve our issue because there are other different groups which are also present, and that would be still left out, and we are only allowed to remove one element. So no matter how many elements in the hash map are there, we this any frequent the size of the hash map greater than 2 is actually a bad case for our condition or for our question, hence we would ignore this case. So so looking back at the case 2, what we had is when we if we have a lone element that is having a single frequency, we can remove that. Or if we have a higher group, we can remove one element from the higher frequency group, just like we discussed in the case 3, that uh, we can only try to remove the elements from the higher frequency group. That way we'll convert the higher frequency group into the smaller frequency group. Okay, so this is what goes in the bottom, and in the top we just exclude the single elements. Now that we have the understanding of different cases, we can move on to our example. That is this, suppose this is the string or the array which we are given, and we will be using the frequency hash map and the count frequency hash map, and we'll update it accordingly. Okay, so at the very beginning, we'll start moving our pointer, that is prefix end. So at this point of time, we'll see if the current vector element, that is the vector value, is present in the frequency hash map, and it's not. Hence, the step 1 would be to increase the value, increase this. So what does this mean is basically having a, that is the vector value, put it inside the frequency FREQ of a plus plus. So what it does is it initializes a key value pair to a corresponding to 1, that is a corresponding to 1. So the next step would be basically this step where we update the count frequency hash map. And how do we do that? We pass on this. What is this? It's basically a passed on to the frequency which gives me 1, and this 1 is passed as a key to the count frequency hash map. Okay, so this the whole purple thing is basically 1, and 1 is passed as a key, and that key is that creates a new element, that is 1 1. Now now at this point of time, we are done updating the whole, both the hash maps and specifically the count frequency hash map, and we need to check whether the current prefix array is satisfying any conditions, and based on that we'll update the result value. So yes, it satisfies the condition, that is the key value pair are equal to 1. Also, since the size of the hash map is 1, and the value is also 1, which in which we can actually cancel one element, will be remaining, the rest of the elements will which will remain is 0. Hence this condition is acceptable. Hence we'll update the result value to 1. Okay. Now next we move our pointer to the next position, and we'll keep on doing the same thing. Let's do that. So the value doesn't exist. So step 1 would be updating and creating an element in the frequency hash map B11. Then step 2 would be update the corresponding count frequency using the uh, free this value as a key to the other second hash map. So what we do is we basically have that key, and that key went down to the corresponding, I mean, that frequency, that the value went as a key and the corresponding frequency was updated, corresponding value was updated. So the next step would be to check now. And yes, it does, because we can eliminate one. Um, we can eliminate any one of the uh, elements, and it satisfies this condition, that is value is equal to length or prefix plus one, prefix n plus one. That's why we'll increment result. It becomes 2. Next, we include C, and the first thing that we'll check is whether it's present or not. It's not, we'll create a new element. That is the step 1, that is creating a new element, and we'll, using the same value, we'll update the corresponding value over here to 2 becomes 3, and we need to check now because we are done with the updating count frequency. So yes, it does satisfy. Count size is equal to 1, count frequency size equal to 1, and the value is equal to length. So we'll update the result. We'll move to the next. Again, we'll check. It's not present, and hence we'll create an element, and the corresponding uh, key, the respective value will be incremented as per the step 2. So we incremented it, and at this point of time we'll check because we are done doing that. Then we observe that yes, it satisfies the condition, hence we update the result value to 4. Next we move on to C. Now this is a little new condition because at this point of time we do find the C in our frequency hash map, right here. So the step 1 would be basically a little different from the previous. And why is it so? Is because if we directly manipulate this element right here, it would affect the it would be affecting the whole relationship between this hash map, the first hash map, and the second hash map. So what we really need to do is we need to make sure to change the linked hash map first and then modify the elements in the first hash map. Okay, so the first step is to basically decrease the value of the frequency, right? So basically, since we are eliminating, since we are converting this 1 to 2 because this the C occurs the second time, so this value right here, we will only have 3 groups because C won't be part of the group having one frequency. That's why the freq vector value, that is C of the value of C, that is 1, goes here 1, corresponding value, that is 4, is decremented, that becomes 3. Now the step 2 is if the value which is decremented, the resultant value is 0 or not. So 4 became 3 and it's not 0, hence we move to the step 3, that is um, frequency of vector value plus plus. And why are we checking the step 2 is because if the value becomes 0, let's say it was 1 and then became 0, then there are no groups present, and we really need to remove that element because at that point of time that element doesn't contribute to any group, hence, and the size of the hash map is pretty critical, hence we really need to remove that. This step is crucial. So what we did is we just updated our C next at the step 3. Next we have step 4, that is now update the corresponding thing. So 2 goes here, 2 must be mapped to 1, that is right this. And at this point, we need to check because we are done updating. So these are four steps which we followed in this case when the vector, the value does exist. So if we check, we have a size equal to 2 and value 2 is equal to 1, and key 2 is 1 greater than the other key. Okay, that's why we will update our result. And we can also clearly see that if we remove end one of the C, we will be left out with A, 1A, 1B, 1D, and 1C. So we'll update our result to 5. Now we'll move on to the next. Over here also, again, we figure out that the value C is actually present um, inside the first hash map. So the first step would be to decrement the um, corresponding element right here, the value. So the corresponding element we goes from C to 2, 2 to 2, of then 1. Then 1 becomes 0. So the next step is if the resultant value is 0, then we need to erase that element. So resultant value is 0, then we need to erase that element, which becomes empty. Now step 3 is basically increment the value. So the corresponding C, that is the vector value, corresponding value, that is 2, will increment it, becomes 3. And the step 4 is basically now, since we have updated this, we need to update the second hash map. So 3 comes as a value, 3 comes as a key, and the corresponding value will become 1. So 3, 1 is pair is introduced. Now we are done with this. We need to check, and we can see right here, even if we manage to remove one of the C, we'll still left out with 2C, A, B, 2C, 1A, 1B, and 1D. So that's not a idle condition. Hence, we won't update our result. We'll just simply move our pointer to the next position. Now over here D is also present, hence we'll follow the same procedure. First is decrement the corresponding value. So D comes to 1, D points to 1, 1 points to 1 right here, 1 points to 3, which will be decremented. It becomes 2. Step 2 is basically if it checks, so the resultant value what we did is not 0, hence we skip this step. And now what we do is we got vector value, that is D, of the value, that is it points to 1, but we want to increase this 2 because D occurs 2 times. So after doing that, we will have the step 4, which is basically creating the element in the hash map. So 2 comes here as a 2-1 pair. Now at this point of time, we also need to check because we are done updating the count frequency hash map. And right here we have 3. The size of the hash map is 3. And like we discussed, this case is not possible. It's not a scenario which we're looking for because again, if we manage to remove one C, we won't be getting our desired solution because it would lead to 1A, 1B, 2C, and 2D having one C removed. So that's not a solution. Hence we ignore it and move to the next case. Again, A is not present, is present, and we look at the first step, that is decrement the value, that is decrement the corresponding value, sorry. So decrementing A points to 1, 1 points to 1, 1 points to 2, decrement 2. This becomes 1. Step 2 is basically checks if the decremental value is 0. No, it's not. Ignore it. Then update the value. So A points to 1, increment it, becomes 2. Step 4 is basically A points to 2, 2, points to this 2, 2 points to 1, increment this, so it becomes 2. So at this point we check 3 elements in the hash map, 1, 2, and 3, hence we ignore this case. We include B. Check if it is present, yes it is. Step 1 is to decrement the value, so B points to 1, 1 points to 1, 1 points to 1, and we decrement it, so this becomes 0. So what we have here is 0. Next step is because it's 0, because this is 0, so we'll erase the whole element. So doing that is like this, the element is erased. Step 2 is incrementing the value, that is B corresponds to 1, that we'll increment that, so this becomes 2. And the step 4 is basically, incrementing the value over here in this hash map. So B points to 2, 2 points to 2, and 2 points to 2, increment this, so 3. Okay, so now we need to check, yes, we have our um, hash map hash map size is 2, and one of the value is 1, right? So the one of the value is 1, and the key corresponding to it is actually greater than the other key. So this is a satisfying condition, hence we'll update our result to the length of the prefix array. And what is this? 8 plus 1, that is 9. Hence the result becomes 9. At last we include E, and E is not present in the hash map. Hence we'll follow the step 1, that is include an element, that is E1, and step 2, that is point the corresponding value in the second hash map. So E points to 1, 1 points to nothing, hence create it. So 1 is to 1 is created. Now since we are done creating it, we need to check size of the hash map is 3, ignore this case. So the very first thing we need to do right here is to actually create these two hash map and a result variable. So there's an unordered map. Why? Because we don't need to uh, worry about the internal ordering of the elements. This will increase our time, increase our speed. Next step is to iterate towards the whole array. For that, I'll be using a prefix n pointer that will just start from 0 and it will go till the end of the nums vector. Now, the first thing what we need to do is we need to fetch the value, that is the vector value a. So for that, I'll declare a vector value variable that stores whatever the value the prefix n pointer points to. Right here, it's at a. Okay, just like we saw in the presentation, we have when the element, if it is not present in the hash map, we follow these steps, right? These two steps. So when the vector value is not present in the hash map, that is, it doesn't exist, what we do, we check from via this condition, that is right here. We do the step 1 and then we do step 2, what we wrote over here. Similarly, the other case, when the element that the prefix end is pointing to is is present, already present in the hash map, then we follow these steps. Okay, so if the vector value is already present, then what we do is we follow these 4 steps. So these are the steps which were written right here. So what this means is the vector value, the first step is to decrement the corresponding um, value in the second hash map. So that's why this is the whole process of, um, I mean, these two cases were the process of filling out the hash map. So in every iteration, what we do is we take the vector value, and then in this highlighted portion, what we do is we update the hash map, update the count frequency hash map accordingly. After this, we'll move to checking whether the current prefix is a possible scenario or not. Okay, so right here, case one equals when the size of the count frequency hash map is equal to 1. That way, we have this if condition. But what if this is the case 2, that is the size is equal to 2? For that, I have this else if statement. And the last condition is when the size is greater than 2, that is 3, 4, 5, or whatever. So to do that, I have written a separate case, and inside it we won't be doing anything. So do nothing. So as you can see, after fetching the value, this was the hashing, updating the hash map portion. And after that, we have this section where we check whether the it falls into any one of the case and it is the possible scenario or not, and thereby updating our result uh, variable. So this is the basic uh, logic. So let's look at this case. But before doing that, we will be dealing with, since we will be dealing with the hash map having a single element, hence we need to have some sort of pointer so that we can access the elements, the key and value. So over here we have, like we discussed in the presentation, we have a key and value picker. With this we can actually access the values. So corresponding to this, we have over here. So this is the pointer, and by doing this, by writing this syntax, I can access the key, and by writing this syntax, I can access the value. Now, looking back at the cases, the subcases, the subcase 1 over here, if the frequency of, if the count frequency dot size equal to 1 and the value is equal to length, then at that point of time, that's our condition. So if subcase 1, if we have value equal to prefix n plus 1, then what we do is we update our result with the length of the whatever current prefix array is. So to figure out the length, since its array is 0 base index, hence the length is prefix n plus 1. In the second subcase, what we have is if the size is 1 and the value is equal to 1. So size is 1 and the value is equal to 1, then we update our result. So we are done with the first if condition. Let's move on to the next else if condition, that is when the size is equal to 2. Again, to access the values, we should have a key value picker. So for that, like in the previous case, I have declared a pointer right here, which can access key 1, the key of the first element, and the value of the first element in key 1 and value 1 respectively. But what about the second element? So we need to introduce key and value plus plus statement, which is right this. What it does, it moves the pointer to the next element, that is this. And for this case as well, key2 and value2 can be accessed by this syntax. So I'm going to access this by this. Now we are done setting up the key and value variables. Moving on to the cases. So like I said, there are two cases mainly, but there are defined in 6 different cases. Okay, so one is the main case is this one main case, second main case, and the third main case. So the very first case is when value 1 is equal to 1 and value 2 is not equal to 1. So the corresponding situation can be described right here. The next case is when value 2 is equal to 1 and value 1 is not equal to 1. Corresponding else if condition is this one. Now the next case, what we have here is when value 1 is equal to 1 and value 2 is equal to 1. That is, both the values are equal to 1. For that, I have written this case. Now, inside these 3 individual subcases, there are further 2 subcases which we need to handle. First, cancelling of a lone element, and second, cancelling of a single element inside a bigger frequency group. Okay, that by uh, thereby converting the bigger frequency group into smaller frequency group. So the first case is when the key 1 is equal to 1, and the second case is key 1 is equal to key 2 plus 1. So the corresponding conditions would be if this, then update the result, and if this, then update the result. Same thing for the second case. Inside it, we have key 2 is equal to 1 and key 2 is equal to key 1 plus 1. So for that, I have written these conditions. If this, then update the result. If this, then update the result. Same thing whatever written over the slides. Now, same case for the last scenario. If key 1 or key 2, any of them is equal to 1, then it's a win-win situation. Otherwise, the other condition is if the and if the absolute difference is basically equal to 1, or you can say any one of them is greater than the other by one value. So that so I've written this. If this condition, then it's a win-win situation. If this condition, it's a win-win situation. So with this, we have covered every possible scenario in the case having size equal to 2. So hence we covered every possible scenario. Now, as you can see, we have been constantly updating whenever the case was found out. Whenever the possible scenario was there, the remaining thing is to return the result, the final result, and that completes our whole code. Okay, so first let's test the values corresponding to this scenario. Let's see if it reads out 9 or not, because the answer was 9, right? So what I've done here is to show you guys that this was the corresponding scenario, right? This is the same scenario and the corresponding values. Like if we have a B over here, so B is over here as well, and that has corresponding values 2, corresponding value 2 right here as well. Same goes for C, 3, 3, 3. Okay, so I have mapped it with a number regard in place of the letter. Okay, so removing this, let's try running this code. And yes, the answer is 9. Okay, let's try submitting the code. And yeah, the code works fine. And the time complexity and the space complexity for this question would be like this. So since we are traversing the entire array only once, starting from the very leftmost end and going towards the rightmost end, hence we are going for off in time complexity, but we are creating a frequency hash map, right? That is actually um, one is the frequency of the elements, and the other hash map is the count of the frequency, right? The occurrence of the frequency, the grouping hash map. So I guess it's O of n as well. I'm not sure, maybe it's O of n square, I guess. Thanks for watching.